Hello viewers, welcome to Senior College Mathematics. Topic of discussion is bearing. Lesson 4, location of a point from another. That is reversed bearing part 2. And we have example 13. Town P is on bearing 315 degrees from Q, while tan arrow is south of tan P and west of tan Q. If tan arrow is 60 kilometers away from Q, how far is arrow from P? From the first line, we have tan P on this bearing from Q. If you look at this given angle, this angle is in the fourth quadrant in clockwise direction. So point Q should be somewhere here. So if you have point Q somewhere here, tan P is on a bearing of 315 degrees from Q. So from this point, you have tan P in this direction. While tan arrow is south of tan P. So this is south of P, and west of Q, this is west of tan Q. So tan arrow must be somewhere here. This is where tan arrow should be. Tan arrow should be south of P and west of Q. The distance between arrow and Q is 60 kilometers. All right, this is one quadrant. It is 90 degrees. If from here to here is 315 degrees, this remaining part must be 0.45 degrees, and this angle is equal to this angle. So if here is 0.45 degrees and here is 90 degrees, this other angle is 0.45 degrees. We are asked to get how far is arrow from P. That is this distance. We can use the sine rule to get the required distance. This is the diagram as I have explained. Because arrow is south of P and west of Q, we have a complete quadrant here, 90 degrees. From this point to this point is 315 degrees. The remaining angle must be 0.45 degrees, which is equal to this angle, alternate angles. In a triangle, the sum of the angles is 180 degrees. So if here is 0.45 degrees and here is 90 degrees, the third angle must be 0.45 degrees. You have the sides labeled as well. How far is arrow from P is the distance between the two towns denoted by Q. We can use sine rule because angle P and side P are given. That is a complete side. So you state the sine rule in this form. In terms of the complete side, you replace the known side and angles with what they stand for. To get Q first, you have to cross multiply and divide both sides by sine 45 in order to have Q standing alone. Sine 45 degrees, we cancel sine 45 degrees. You are left with 60 kilometers as the distance between tan arrow and P. Example 14. An airplane flies from tan S on a bearing of north 45 degrees east to another town y, a distance of 200 kilometers. It then changes course, that is direction, and flies to another town z on a bearing of south 60 degrees east. If z is directly east of s, calculate correct to 3sf. A, the distance from s to z. B, the distance from y to sz. This distance must be the height of the triangle that will result. Solution. We said that in practical bearing problems, we make use of 3-digit bearing. So if you convert this one to 3 digits, you have 0.45 degrees. You convert this one also, you have 120 degrees. The movement starts from tan S on a bearing of 0.45 degrees to tan Y. Let's attend to that first. So let's take this as tan S. So tan Y, the bearing is 45 degrees, 0.45 degrees. The distance is 200 kilometers, so here is 200 kilometers. At tan Y, the airplane changes direction and move to tan Z, 120 degrees. That should be in the second quadrant. You have it somewhere here. But pause, come here. Z is directly east of S. So tan Z should not be above or below the east of S, but at the same level. So let's extend this to this point. So you come here, you draw it. So here is tan Z. This is tan Z. So if from here to here is 45 degrees, here is also 45 degrees. This angle is equal to this angle. From here to here is 120. Here becomes 0.60 degrees. So the whole of this angle is 105 degrees. This side is 200 kilometers. To get the distance from S to Z, we can use sine rule. We can use sine rule because this side and this angle is known. Now here is 105 degrees. Here is 45 degrees. If you add these two angles, subtract it from 180, you get the third angle. So this side is complete. Here is 105. To get this side, it must be sine rule. You have the diagram as I have explained, with all the angles and sides were labeled. You can see 105 degrees. The given direction of tan S to Y, 0.45 degrees. The whole of this quadrant is 90 degrees. The remaining angle must be 0.45 degrees. This angle here is equal to this angle. Alternate angles from here to here is 120. So this remaining side must be 0.60 degrees. So 105 plus 45 degrees, that is 150. The third angle, this angle is 0.30 degrees. So you label this as side S, the side opposite side Z, the side opposite angle Z. You have Y and S. So we have to get the distance from S to Z denoted by Y. A part of the question, the distance S to Z is by sine rule. You state the sine rule in terms of the complete side. That is y over sine y equal to z over sine z. You replace the known side and angles with what they stand for. You cross multiply and divide both sides by sine 30 degrees to have y standing alone. After simplification, you have this result. You multiply, you have this result. After division, you have 386.36 kilometers. Therefore, the distance from S to Y, from S to Z, is approximately 386 kilometers. B part of the question, the distance Y to SZ, this is SZ, this is, so you move from Y to SZ, will be triangle SYZ altitude or the perpendicular height. The altitude or perpendicular height. So from the diagram, you carve out triangle YSZ. This angle is 105 degrees. This angle is 045 degrees. This angle is 030 degrees. We have this side to be 200 kilometers. This is the height, the required distance. So we have to consider triangle SMY. It is a right angle triangle. This is opposite to this acute angle, and this is the hypotenuse. It must be sine 45 degrees equal to h over 200. That is opposite over hypotenuse. Multiply through by 200 to clear fraction. You have it in this form. And 200 times 0.7071, the value of sine 45 degrees. After multiplication, you have this value. The distance from Y to SZ is approximately 141 kilometers. Example 15. Two boats, A and B, left a port C at the same time on different routes. B traveled on a bearing 150 degrees and A traveled on the north side of B. When A had traveled 8 kilometers and B had traveled 10 kilometers, the distance between the two boats was found to be 12 kilometers. Calculate the bearing of A's route from C. Solution. The two boats left the same port, that is C. So let's have somewhere here as port C. B traveled on a bearing of 150 degrees. From the north, you have this point to be 150 degrees. So we have point B somewhere here. This is point B. This is point B. Here is C. The question says that A traveled on the north of B. This is B, so A follows this direction. A follows this direction, so we have A, both A somewhere here. We can simply close this part together to have a triangle. So this angle here, the whole of this angle is 150 degrees. This remaining angle must be 030 degrees, which is equal to this angle 030 degrees. And we have the various distance covered. When A had traveled 8 kilometers, so here is 8 kilometers. B had traveled 10 kilometers, so here is, okay, let's take it again. When A had traveled 8 kilometers, B had traveled 10 kilometers, the distance between the two boats was found to be 12 kilometers. So here is 12 kilometers. Here is 12 kilometers. Then A had traveled from the same port now, from the same port. So this is 8 kilometers. Then B, this is 10 kilometers from the port. All right. So with this, we can find the bearing of A's route from C. This is A. The bearing of A from C is from this north to the line joining A and C. The solution continues. You have the diagram as I have explained earlier. Port C, you have A, you have B. This angle is 30 degrees. The distance between the two boats is 12 kilometers. The boat A from the port C is 8, then B is 10. You label respectively. Now the bearing of A from C is from the north to that line that joins C and A together. Now this entire angle is 150 degrees. What we need is just this part. It means if you get this angle, you subtract it from 150 degrees. In triangle ABC, the three sides are known. Therefore, you can get angle theta by cosine rule. The bearing of A's root from C is 150 degrees minus theta. Theta can be obtained by cosine rule. In trigonometry, I told us that one of the conditions of applying cosine rule is that the three sides of the triangle are given. So you have this rule. The rule in this version is in three forms in respect to each of the angles. Now, this is angle theta, which can be seen as angle C. So you have cos C, which is cos theta, is equal to A squared plus B squared minus C squared over 2AB. You replace all the sides with what they stand for in this form. After simplification, you have this result. After addition and subtraction, you have this result. After division, you have 0.125. To get theta, you take the inverse of cosine of both sides. Theta becomes 82.81 degrees. So the bearing of A's root from C becomes 150 degrees minus 82.819 degrees. You have 0.67, at least in 3 digits, 0.181 degrees. To one decimal place, you have 0.67.2 degrees as the required bearing. End of lesson 4. Thanks for watching and learning. Don't forget, watch out for more from the voice of Peter Kos. Lastly, if you are not safe, your life is in crisis, your life is in trouble. To avoid all of that, you have to give your life to the Lord Jesus Christ and confess Him as your Lord and personal Savior every day of your life. If you are saved already, congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Be good to yourself. Stay out of trouble. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Find something good and genuine to do with your hands and your brain, and the Lord will bless you. Goodbye and stay tuned.